If you look at this question, students, it's told in the problem x, y, z are all different, which means x, y and z are unequal to each other. That's the meaning of it. And the value of this determinant is equal to 0 is told in the problem. According to the property of a determinant, we can now split this determinant x, y, z, x square, y square, z square, and then 1, 1, 1, and then plus x, y, z, x square, y square, z square, and then x cube, y cube, z cube. Is it right? This value will become equal to 0. So when nothing is there here outside, this number is 1, right? 1 into determinant of x, y, z, x square, y square, z square, and then 1, 1, 1. Is it okay? 1, 1, 1. Plus, I can take out x common from the first row, y common from the second row, z common from the third row. So x, y, z, if I take out common, I will be left with 1, 1, 1, x, y, z, and x square, y square, z square. Is it right? This value will become equal to 0. Now same way, we will interchange C1 and C3, and then C2 we will interchange with C3. This is a very common concept now. We have seen in a lot of questions. So when you interchange in the first place, determinant will become negative. Second place, negative into negative becomes positive. So I can write 1 into x, x square 1, y, y square 1, z, z square 1, plus x, y, z multiplied with x, y, z, x square, y square, z square, and then 1, 1, 1, that is equal to 0. So what we'll do, we can take out the determinant common. So I'll be left with 1 plus x, y, z into determinant of x, x square 1, y, y square 1, and z, z square 1. This part will become equal to 0. Now from the competitive exams point, I'll tell you, see, there are two parts which is contributing to make the value 0. Alright, so if x, y, z are not the same, then their value will never become equal to 0, right? I'll say like this, R1 forms R1 minus R2 and R2 forms R2 minus R3. If I say like this, I can explain this to you better. 1 plus x, y, z, determinant of x minus 1, x square minus y square can be written as x plus y into x minus y, and this part becomes 0. Y minus z, y plus z into y minus z, and then this part becomes 0, and z, z square and 1. This value should become equal to 0. Because x, y, z are not equal, this value will not become equal to 0. X minus y can't become 0, y minus z can't become 0, z can't become 0. X, y, z are not equal. Even if z becomes 0, 0, 0, 1 is not contributing to make the determinant 0. So it is understood and implied that 1 plus x, y, z, that is equal to 0. So can you tell me what is the answer that we get? X, y, z is equal to minus 1 is the answer.